Hey guys, it's me Sharon. So today I'll be doing a video about physics. We'll be looking at thermodynamics or short-term thermal physics. So I'll be doing ideal gas equation, how it's derived and its derivation. So yes, so this is not the textbook version, guys. It's just how I'm gonna say my own words and how I'm gonna say in a like accentuating manner. So I'll be saying that now. So now, what is an ideal gas? So ideal gas means perfect. So if it has to be perfect, it has to follow the three fundamental laws of gases. So I can just say that an ideal gas obeys the fundamental laws of gases. So, an ideal gas obeys the fundamental laws of gases. So, according to Boyle's law, according to Charles' law, according to Avogadro law. So guys, what is Boyle's law? And its other equation V is this one. I'm saying it is in terms of constant. So the term is, so by Boyle's law it is V is equal to 1 by P. V is equal to 1 by P, where T and N are constant. T and N are constant. You have to remember this, guys. Then to Charles' law, it is P is indirectly proportional to T, where P and N are constant. So this is just simple. V is directly proportional to N. Yeah. So V proportional to N, where now P and T are constant. So guys, all of these laws talk about volume and volume only. So let's check. Yes, PV or V by T is equal to constant, or V by N is constant. So also says V by T is constant. So by Charles and so by Boyle's law, we can say that it's just 1 by P, or it's just PV is equal to constant. By Boyle's law, no, by simplifying these three equations. So by simplifying the three equations, we get Boyle's law, Charles' law, Avogadro's law. So it's V 1 by P, and there's P over here. So let's just take this, guys. So if P is multiplied directly over here, it's PV. So PV is equal to 1. So we can just take that 1 as by N by T, we can just say that's constant. PV is equal to constant. Now by Charles' law, it says V directly proportional to T. So we can say that V by T is equal to constant. Now, this is the same thing. This is V by N is equal to constant. Now guys, here is the most important thing. So, by combining, okay, so let's take this as 1, 2, 3. So by combining these three we get, so guys, from, okay, so look at the first letters of each. So there's P, V, V. So what is most common in P, V or V? So you can take the P, since it's the only P over here. So even you can take the second letter. So there's no single P's in there. So we just take P over here. Or since it is according to Boyle's law, the volume of a gas is directly proportional to the change in temperature, we can just take as PV is equal to constant. So let's just take it over here, because even though if we just, there's also another method by, which is common in each. And since, okay, we can just take PV. So PV is equal to, so just forget about common. So the first one, Boyle's law, we gotta put PV over here. So according here, V, so there's two V's over here. So what can we put is that we can cancel that out. So V cancel, and now what is there? NT. So this is constant. So P is equal to NT, right? Oh, I'm sorry. It's PV by NT is equal to constant. So guys, I'll tell you how it works. So how we combine all these three equations. So first, the first primary source is Boyle's law. So we can just put P over here. So what is common in VT and TN? VN. So V is common. So it's like, just V is common. You can just put 1 over here. No. You gotta cancel both of them, and we gotta put N and T. So imagine if it just comes to Tn. So what law follows that temperature is reciprocalized of number of moles? So if N by T comes, it obeys Avogadro's law and Charles' law. So you can put it as that, N by T. So that's why N by T is capital letter. So that's how it works. And then the next one. So the above relation is called the combined law of gases. If you consider a gas which contains mu moles, so let's say that we don't know how much molecules these have, so we can just consider as mu. So this is mu. So we just consider it as mu moles of gas. The number of atoms will be equal to mu times the Avogadro number Na. That is, N is equal to mu of Na. So that means by Avogadro's number, equal volume of gases contain equal molecules of gases. We can just say that N is equal to mu of Na. Since N is equal to mu of Na, so we gotta remember this because we gotta put this in derivation. You should also write that down, guys. So how we got mu and stuff. And then next, and let's take this as equation 5. So so we can just see that PV and T mu of Na. So by combining, using equation 4, equation 5, which can be written as, so it can be written as, so guys, so look, there's N over here. So what can we do is, by substituting 5 in 4. So PV by, for in n's place you can put mu of Na by, yep, and is constant. I hope you guys understood how this works. And the volume and the value of the constant the above equation is taken to be in Kb. So we can take the value of this constant into Kb. So it can be taken as Boltzmann constant by taking Boltzmann's constant. So what is Boltzmann constant? 1.38 joules mole times 10 power minus 23 joules per Kelvin minus. So this is Boltzmann constant. So we can take the value of constant as this. And the next thing, hence. So guys, so this thing, so just put it over here. So PV by mu of NAT is equal to, so what's the constant? So we have a constant which is Kb. You can put Kb over here. So Kb. Now the next step is actually very crucial. So we have to remove this sign. So what is Kb? What does this have? So numbers. So at this point we just don't need numbers. Instead we need the variables and the different scales. So we can take that PV is equal to mu of Na Na. So since temperature will go over here, because this is the only measurement in temperature, so it will go over here, and Kb will come here. Kb by T. So guys, we can take this. This is R because this is the universal gas. The universal gas symbol. I won't say a symbol, but rather as a sign abbreviation. So since mu of Na Kb is equal to universal sign of gas. This set as R. We can say that R is equal to mu of Na Kb. Now what does it say is that I had to find the value of R, so it's just simple. So 8.31 K minus 1. So from this we can say that moles. So So we can say that this is constant and this by RT. So PV is equal to RT and voila. This is my own derivation.